thanks to those who sent in their questions. This is the beginning of the review for the test. We're going to factor quadratic trinomials in the form of x squared plus bx plus c. So the first problem we have is x squared plus 11x plus 10. And this is just your basic x problem. So what multiplies to get you to 10, that would add to get you to 11. And that would be 10 and 1. 10 times 1 is 10, 10 plus 1 is 11. So it's simply x plus 10, x plus 1. And remember, you can always check it through FOIL or double distribution. X squared, 10, 10x plus 1x is 11x. So now this one down here, it's not in the form x squared plus bx plus c, but remember, the first thing that you're going to look for is the GCF. And you can pull out a greatest common factor of 2. So we end up with x squared plus x minus 2. Now, looking at this one, you have to still think, can I break this down? Let's see. We have negative 2 and 1. What numbers multiply to get you to negative 2 that could add to get you to 1? Well, I know that 2 times 1 will get you to 2, but I need it to be a negative where the sum would be a positive. So 2 times negative 1 is negative 2, and 2 plus negative 1 is 1. Don't forget to bring this guy down. And we end up with, 2x plus 2x minus 1. Don't forget this. Here's another one. X squared plus 5x plus 6. Again, what multiplies to get you to 6? That adds to get you to 5. 3 times 2 is 6. 3 plus 2 is 5. X plus 3, x plus 2. That's one of my favorite problems. Now we have 3x squared minus 18x minus 48. Now again, you're probably thinking this isn't in the form of ax squared. Think, would you really expect me to do negative 48 times 3 and have you do the AC? Possibly, but I can pull out a 3. X squared minus 6x minus 16. And then here's where you can go ahead and say negative 16, negative 6. I have 8 times 2, but I need negative 16 that it would add to get me a negative 6. Don't forget the 3, x minus 8, x plus 2. Now here are some questions on factoring quadratic trinomials where you have an ax squared. So looking at the 2, the 9, and the 10, there's no GCF there, so we have to multiply a and c to get 20, add to get 9. 5 times 4 gets you to 20. 5 plus 4 gets you to 9. Remember that we're going to start off the parentheses with 2x because of the method we're doing. Plus 5, plus 4. Over here we can divide by 2. We have 2x plus 5, x plus 2. And you can check it. 2x times x is 2x squared. 5 times 2 is 10. 5x is, there's your 5x, and there's your 4x, which gives you the 9x right there. Next one we have 3 times negative 5 is negative 15 with a negative 2. 5 times 3 gets you to 15, but we need a negative 15 and a negative sum, so we have a negative 5, 3x minus 5, 3x plus 3. Divide these by 3, 3x minus 5, x plus 1. Now remember, you can always pause the video here and try these on your own, and then come back and see if it matches up. 2 times negative 9, negative 18, positive 3, 6 times 3 gives you 18. We need a positive 3 sum and a negative product. So we have 6 and negative 3. Simplify here. X plus 3, 2x minus 3. Down below, 3 and 4 is 12, and negative 8. Got 12 and 1, that doesn't work. 3 and 4, 6 and 2. Well, 6 times 2 is 12, but that's not going to get me to negative 8. So it looks like I have to have negative 6 times negative 2 gives me that positive 12, and negative 6 plus negative 2 gives me that negative 8. 3x minus 6, 3x minus 2. Simplify, x minus 2, 3x minus 2. Now, perfect square trinomials are just a special quadratic, and if you recognize it, great. If you don't, you can still do the x. With this x squared plus 8x plus 16, you can still do this. But if you recognize perfect square, and that 4 plus 4 is 8, this doubled, you don't have to go through this and work it out that way. But it doesn't matter which method you do it, and it doesn't matter which answer you give me. This one's fine, and that one's fine. This is just a shortcut, and you can do it the old-fashioned way, or you can start to look and try to save yourself some time. Like looking at here, we have perfect square, but I need a negative. So negative 9 times negative 9 is positive 81, and negative 9 plus negative 9 gives you that negative 18. Now these are factoring the difference between two perfect squares. What you'll notice the way these look versus the other ones is there's only two terms. And the key here, difference, meaning the subtraction sign, two perfect squares, these terms right here. So do we have a perfect square with x squared? Yes. And with 9, square root is 3. One must be positive, one must be negative because we have no middle term. Plus 3x minus 3x is what takes away that x position in the center. Doesn't matter also if it's written this way. Still, 25 is a perfect square. There's your difference, 5 minus x, 5 plus x. Doesn't matter if it's 5 plus or 5 minus. That's your difference between two perfect squares. Key is, you got to look for difference. Now here we have 9x squared. Is 9 a perfect square? Yep. 3x and 3x. 16 minus 4 plus 4. Finished. Down here we have x squared and 100. We've got two perfect squares, but it's a plus sign. This is factored already. We're done. You cannot say x minus 10, x plus 10. It's not going to give you the same result if you were to FOIL or distribute again. It has a plus sign. That's the biggest key. This is not a difference between two perfect squares. Don't let that one trick you. Here's another one of my favorite ones. We have x to the fourth minus 1. Got a difference. And we have two perfect squares. We have x squared minus 1, x squared plus 1. Now, this is the difference between two perfect squares. So we can still break this down into x plus 1, x minus 1, but don't forget we have to bring this down as well. So this is your final answer. Another one of my favorites. So lastly, we have choosing the right method, or how do I know which factoring procedure to do? So we're looking here, 3x plus 12. We have two terms. Not 3, we have 2, and it's a plus sign. So the only factoring that we've done that has had two terms has been the difference between two squares. Well, this isn't a difference. and it's not two perfect squares. But the key that we have talked about is look for your GCF first. Is there a GCF with 3x and 12? Yes. So go ahead and take out that 3, and you're done. This is done. Don't try to do anything more. You've got to start out slowly with these types of problems before we build into the other ones. 2x squared plus 10x plus 24. Again, GCF. Do we have one? Yes. Take the 2 out. X squared plus 5x plus 12. Are we done? What two numbers multiply to get you to 12? That add to get you to 5. Well, you've got 12 and 1, 2 and 6, and 3 and 4. None of those combinations are going to get you there to 5. Don't try to force it. This is finished. It's all finished. Okay, this problem here is 5x squared plus 19x plus 12. So we have no GCF, and this is greater than 1, so it looks like we have to do 5 times 12, which is 60, and then 19. So what multiplies to get you to 60? That's adding to get you to 19. 1 times 60, 2 times 30, 3 times 20. Let's see, 60 divided by 4. Oh yeah, 15 and 4. 5x plus 15. 5x plus 4. Divide by 5. X plus 1. 5x plus 4. Nope, it's not x plus 1. X plus 3. Sorry. X plus 3. 5x plus 4. Did I know I made a mistake? I was looking at 3 times 4 is 12, so you always got to go back and double check. It's going a little too quickly. Last one on this page, x squared plus 2x plus 4. Let's see, 4 and 2. What numbers multiply to get you to 4 that add to get you to 2? Well, I got 4 and 1 and 2 and 2. Nothing is going to work. This is factored. This is done. Cannot do anything else with this one. Don't let this one trick you, please. Don't tell me it's x plus 2, x plus 2. Just take your time. Oh, this is a good one. 3x squared minus 243. Okay, I got a difference here. That's not a perfect square, but that's a really big number. This is a perfect square, x squared, so I'm going to see, what's 243 divided by 3? Do I have a GCF here? 3 into 24 is 8. 8 times 3 is 24. 3 into 3 is 1. If I take that 3 out, I end up with x squared minus 81. I do now. I have the difference between two perfect squares. X minus 9, x plus 9. That's another good problem. Be careful with these. You can always find your GCF.